The topic is weather systems. We're going to be talking about frontal precipitation and severe weather, particularly tornadoes and hurricanes. But before we do that, I've got to go over the concept of air masses, lecture number 5. So I want to begin with defining an air mass. It's a large body of air with uniform temperature and moisture characteristics. And so, the atmosphere is sitting over the Earth's surface, and the atmosphere tends to take on the property of that surface. So, for instance, say in wintertime over Siberia, the air is sitting over Siberia in wintertime, and so the atmosphere takes on the properties of Siberia, so that we spawn or create an air mass that is very cold and dry. Because it's sitting over land. Maybe another opposite example, say like the Gulf Caribbean Sea in summertime, and so the air is sitting over this warm ocean, and so the atmosphere takes on the properties of that ocean. So we spawn or create an air mass that's very warm, humid and and moist, creating rain. So there is a classification system of air masses, and it's a two-letter system, and the first letter is a small letter, and the small letter gives you some idea as to the moisture content of that air mass. So we use a small m, meaning maritime, and that's going to always be a rain producer, or a small c, meaning a continental source area, and it's going to be dry. Now, the second letter is a capital letter, and it gives you some idea as to the temperature. The coldest air mass is a capital A, meaning an Arctic source area, or even from the poles, the Arctic, Antarctic Circle, South Pole. So by far the coldest air mass. A capital P is a polar air mass. Now, this is kind of stupid. I mean, the classification is a problem for me here. It's not from the poles. It's actually from a mid to high latitude location, like 50 to 60 degrees north and south latitude. So just below the Arctic Circle, or just above the Antarctic Circle. And we'll get that straight, in the remaining lecture. But it's not from the poles. Then we take a big jump on down to a capital T, for a tropical source area. And that's going to be definitely a warm air mass. And then by far the warmest are air masses that are spawned near the equator. So we use a capital E. Now what we're going to do is put these two letters together. And on Earth, there are 6 air masses. And we're going to go over the properties of the 6 air masses found on Earth. Now of the 6, there are 2 of particular importance to us because they clash in the United States, creating frontal precipitation most commonly. So we're going to star those. But anyways, we're going to start with the actual two-letter classification, and then we're going to kind of restate what the letters are saying. We're going to say the source area, and you'll see that in just a minute. Kind of the average temperature of that air mass, daily, high and low and through the year. The water vapor content in grams, and we'll just kind of compare the amounts. And then we're going to mention whether that air mass is stable or unstable. And we're going to see the pattern is, continental source areas are going to be stable, and they're always going to be dry because they're the source areas over land. And then we're always going to see the maritime source area is going to be unstable, because it's got a source of moisture, and it's always going to be a rain producer. So that's definitely a pattern we're going to see. We're going to start at the equator, and so the first one of the 6 is ME. So it's called maritime equatorial. And so you see the second column is actually redundant because the classification is telling us this. It's oceans near the equator. So on the test, you're just going to see these letters, and you need to be able to read them. All right. So maritime equatorial air is very warm, and to have an average temperature of 81 is very, very warm. And then warm air can hold a lot of moisture, and certainly, we've got, oceans near the equator. So this is definitely our most the most water vapor we're going to see in all of the air masses. And this is very unstable. Now, this is the air mass that creates the equatorial low pressure belt and the intertropical convergence zone, and, creating enormous amounts of precipitation. Now, the second one is one of the important ones, definitely. I have it actually double starred because it's so important to us. It's called maritime tropical. And so this is oceans near the tropics. And so this one is so important. I'm actually giving you, a good example for North America. And so this would be the source area of the Caribbean Sea, Gulf of Mexico. And the average temperature is 75. This daily high, daily low, and then, winter, summer season. And so that's still a very, very warm air mass when you have an average temperature of 75. It's got a source of moisture since it's, tropical oceans. And so it's definitely warm and moist. And so it's definitely a rain producer. Now, why do I have this one double starred? This is our air mass, right? This is the air mass of the southeastern United States, of Louisiana, right? This air mass dominates our weather all summer long, and then up to about a third of winter time. And so this is our air mass. We know it. It's, warm and humid, and that's what we have most of the year. So we're going to be using that in another lecture. All right. Now, let's just stay in the tropics, but let's just say in the United States, let's move west, right? The same latitude, put to the deserts of the southwestern United States. So this third one is called continental tropical. And so this is the air mass that creates the great deserts of the world, like the deserts of the southwest U.S., the Sahara, Australia. And so this is the subtropical high deserts. This is the air mass associated with that. It's still, quite warm, quite warm. Surprisingly, it has a lot of moisture, but it's definitely stable. And the reason why it's dry is because in the desert, in the day, we have a lot of heating. And what does heating do to relative humidity? It keeps relative humidities low. And so remember, because we have excessive heating, relative humidities tend to be quite low. And so definitely, it's very, very stable. Number 4 is called maritime polar. Now, this is not coming from the poles. This is kind of the problem with the classification, but I can't change it. But what polar means is kind of mid to high latitude oceans. Like for us, around North America, this would be like the North Pacific Ocean or the North Atlantic Ocean. And the air mass on average is quite cool. Right, an average temperature of only 39 degrees. And now it is a rain producer, but it only has, on average 4.4 grams of water vapor. And, it's, got a source area of an ocean, so it's definitely unstable. And again, it's kind of surprising. It is a pretty good rain producer. It only has 4 grams, less than the deserts. And it's kind of the opposite thing. Because of excessive cooling and chilling of the air, what does that do to relative humidities? It keeps them high. And so because we tend to have high relative humidities, up to 100% relative humidity, this is definitely a rain producer. All right, number 5 is another starred one. We're going to be working with this one when we're talking about fronts in our next lecture. And so this is another, polar, but this is now continental polar. So kind of mid to high latitude locations over continents. And so since I've got this starred and we're going to be using this, classic source area for this in North America would be Canada, particularly Canada in winter time. And so the average temperature of this air mass is 12 degrees Fahrenheit. It's amazing. It's, this air mass is extremely cold in Canada in winter time. And so that winds up, lowering the average temperature. So over a land mass, so it's very, very dry, and cold air certainly can't hold much moisture. And so it's definitely stable. And so we get continental polar air behind cold fronts in winter time. So after the front moves through, we've got clear and cold conditions, and representing the Canadian high pressure system, moving out of its source area in Canada. So we'll be working with maritime tropical air masses coming from the Gulf, and then it's going to battle, with frontal systems with Canadian cool, dry air coming from the north. And then our final air mass is continental Arctic. Right? Or if you're in the southern hemisphere, continental Antarctic. And so this air mass comes from the poles, right, and near the Arctic Antarctic circles. And by far, this is the coldest, right? Cold polar air. Average temperature is -51. Extremely dry. This is definitely the most stable air. And this is the air mass that creates the polar highs, creating very cold, dense, sinking air. Now, occasionally, in some winters, we do get continental Arctic air. Not every winter, but it's when we kind of have maybe a record-breaking cold, temperatures for several days, well below freezing, or even in the teens. So we do get this sometimes, but more commonly it's continental polar air behind cold fronts in wintertime, but we do see continental Arctic. All right. Well, all the air masses, they have a source area, and then they tend to build up and they'll move out of their source area. And so they can become modified. And I've got an example here of air mass modification of continental polar air, in its source area in northern Canada, and it starts out as 50 below zero Fahrenheit, and the cold air is building up in wintertime and starts to spill out, and it tends to move southward behind a cold front, and as it's moving southward, it warms up, and so after that cold front moves through, it's not going to be 50 below zero for us. I mean, it'll be freezing, or in this example, they've got it really cold down to 25. So air masses definitely can become modified for sure. This is the final slide that I want to show you. These are the air masses that I've just gone over that affect North America. Now, the only one that's not shown here is maritime equatorial. We're mid-latitude, kind of tropical mid-latitude location, so we're not at all affected by, equatorial air. So that's the only one. Well, let's start with our air mass, maritime tropical, source area Gulf, Caribbean. And this one has its source area, and it tends to move northward, bringing, warm and moist conditions to the, the eastern half of the United States. And it becomes modified. We get the full brunt of the humidity and the rain. But when it moves northward, it becomes modified. It actually dries out a bit. Now, for them up in those northerners, it's they complain about how humid it is. But if a Louisiana person is up north, when an empty air mass moves there, it's dry for us. I mean, we're always wondering what they're complaining about. But it does dry out, but it's still, quite humid for people not used to it. Another source area is in, the Southern Pacific. It's not as dominant or as important as the Caribbean one. It does bring moisture to the deserts of the southwestern United States, but certainly, not as much or not as dominant. It's pretty much blocked by the continental tropical air mass, the high pressure system creating the desert conditions of the southwest and U.S. and Mexico and other desert areas too. Let's move on to maritime polar in the Pacific, North Pacific, and it moves in the westerly winds out of its source area and brings abundant precipitation to the Pacific Northwest. And so it gets blocked by the high mountain ranges. And so this is the source area of all of that orographic precipitation. Now, the MP air of the North Atlantic isn't quite as dominant as the North Pacific because the westerly winds tend to pull this air mass eastward, and really dominates the weather in in Western Europe, bringing cool moist air to Europe. But it does affect New England a bit. Right, and finally, let's move up to Canada and the Arctic Circle near the North Pole. And we've got our continental polar air, cold and dry, and then very, very cold and dry continental Arctic near the Arctic Circle. And so these two air masses can build up, particularly in wintertime, and then move southward. Right? And as they move southward, they'll definitely bring cold conditions, but they do become modified. So in our next lecture, we're going to be doing frontal precipitation, and we're going to be working with continental polar air moving southward behind a cold front versus a warm and moist air, moving northward behind a warm front. So we'll be talking about frontal systems battling in mid-latitude locations like the United States. End of lecture.